Hello everyone, Jeff Holland here, and welcome to Ignite. I'm joining you today from Microsoft Studios and thrilled to share how Microsoft is empowering you to innovate with cloud native and open source on Azure. The future is defined by accelerated innovation. Much of this innovation will be digital and take the form of new applications, and the apps of the future are cloud native. These apps are designed to take full advantage of the latest innovation in public cloud, intelligent and infused with AI to provide advanced insights, quickly able to incorporate open source technology and libraries from across the globe. Now, thousands of customers in every industry are building and running modern cloud-native applications on Azure today. Using cloud-native design patterns helps many of our customers achieve the agility, reliability, scalability, and security demanded by the next generation of apps. Let's talk about a few examples. The next generation of apps are being built everywhere and are now out of this world. We see innovation of every industry. Space is going through a major transformation period with new cloud-native apps built with open source. An application I'm really excited about is genomics testing on the International Space Station with HPE Spaceborne Computer 2 and Azure. All major components, both IIS-based and Azure-based, for these experiments were written in Python and Bash using Visual Studio Code, GitHub, and the Python libraries for Azure Functions and Azure Blob Storage. Another industry where we've seen innovation on apps over the past couple of years is healthcare. When New South Wales Health Pathology began looking for solutions to modernize its technology, staff were driven by a need to provide access to quality care across the entire state of New South Wales. They chose Azure Kubernetes Service, Azure Functions, Azure IoT Hub, and Azure Cosmos DB to implement a large-scale digital health platform. There are also great examples of innovation on retail. Every day, more than 1 million travelers rely on timely services of ÖBB, Austrian Federal Railways. This is Austria's largest mobility services provider. They migrated Ticket Shop, their ticketing issue platform, to run on containers on Kubernetes service, and migrated some 11 terabytes of data from on-premises Oracle servers to Azure Database for PostgreSQL. This allowed them an increased degree of automation and frees up resources for operations so they can focus on DevOps rather than keeping an eye on infrastructure. Now, open source is also a key differentiator for many of our customers interested in driving digital transformation efforts that lead to better business outcomes. Based on research by McKinsey & Company, open source adoption is the biggest differentiator for top-performing organizations. Organizations who are best in class on open source capabilities score 30% higher on innovation and 20% higher on developer satisfaction. Open source software is an integral part of development at Microsoft, aligned with our goal to empower all developers to be successful building any application using any language on any platform. And we're committed to building open, flexible technology and working with the open source community to grow together as an industry. Our contributions span multiple areas, from operating systems to programming languages, from data and AI to web. We also focus on cloud-native development, making writing microservices and using Kubernetes easier with projects like Dapper, Helm, and Kata. Microsoft is also an active collaborator on the Postgres community and Postgres committers, and they are members of our team too. With Azure, we're constantly providing capabilities that can help meet your needs to work with open source. With the increase in open source adoption, it's imperative that it runs smoothly on the Azure cloud. On Azure, you can run multiple apps and increase workload performance and security while also optimizing your IT costs. We want you to focus on building your application and not have to focus your energy on infrastructure. And we're excited to show you how we are making Azure the best cloud for developers and IT professionals. Today, we'll be showing you our latest innovation for cloud native and open source on Azure and how we're helping all developers to build the apps of the future. So let's start by talking about the importance of hybrid cloud native apps that can run anywhere. And what do we mean when we say cloud native? In simple terms, cloud native refers to packaging application code and dependencies within containers, deploying microservices or event-driven functions, and exposing events and APIs, all managed with DevOps processes and tools. Technologies like Kubernetes, containers, serverless functions, APIs, and DevOps are all how developers come to get new agility, reliability, and face the security challenges that they have today. Now, developers today often gravitate towards Azure's suite of application services because they're highly optimized for productivity and deeply integrated with both GitHub and Visual Studio Code. Azure App Services makes building and managing web applications and APIs easy, with a fully managed platform and features like auto-scaling, deployment slots, and integrated web authentication. Azure Functions makes creating event-driven programming simple, with state-of-the-art auto-scaling and triggers and bindings across Azure services. Azure Logic Apps produces automated workflows for integrating your apps, data, and services with backend systems, and a library of more than 400 connectors. Azure Event Grid simplifies event-based applications with a single service for managing and routing your events from any source to any destination. And finally, Azure API Management provides a unified management experience, full observability across all internal and external APIs. And today, we're excited to announce the preview capability for GraphQL pass-through, and also the general availability for native support of WebSocket APIs. With Azure App Services now actively serving over 2 million websites and Azure Functions delivering over 1 trillion executions every month, it's clear that these are services that developers love. And we recently announced the preview capabilities of Azure Application Services to run on Kubernetes. These application services can now run anywhere across Azure, on-premises, AWS, GCP, all with Azure Arc. Any Kubernetes cluster now connected through Azure Arc is now a supported deployment target for these application services. With these updates, you can innovate faster by using Azure's suite of application services, all tailored to real-world application patterns, loaded with unique features, and optimized for developer productivity. And developers don't just have to choose between the productivity of Azure Application Services and the control of Kubernetes. You can now run those same Azure Application Services on top of Kubernetes. And finally, developers don't have to build and maintain custom solutions to run in non-Azure environments. You can use the same set of technologies across your hybrid and multi-cloud applications, all powered by Azure Arc. So what's enabling the multi-cloud, multi-edge vision? It's Azure Arc. Azure Arc brings cloud operations anywhere for your cloud-native applications. So first, Azure Arc helps you build cloud-native apps anywhere at scale. You can use DevOps techniques to deploy and manage Kubernetes apps with your choice of any certified Kubernetes distribution. Azure Arc also provides for you a single pane of glass, so you have central visibility through the Azure portal to help govern your applications, understand the compliance, and how the systems are working together. And finally, Azure Arc works with any CNCF-conformant Kubernetes cluster, so that you can bring your Azure Application Services anywhere to any cloud or on-premises. One of the goals we have with Azure Arc is to meet you where you are with your existing investments. As a developer, you get tremendous flexibility and convenience with Azure Arc-enabled services. It doesn't matter where your applications need to run or on what infrastructure. When combined with the use of Arc-enabled data services like Azure Postgres and Azure SQL, which you heard about earlier today, applications and their data can now run anywhere using fully managed cloud services, an industry first. Now, the important thing to note is that the way you deploy does not change. You can continue to use your existing tools and best practices and get the benefits from a seamless and consistent experience. So to show you how this all works, let's see a demo now of hybrid cloud-native apps with Azure Arc. Okay, so let's take a look at how any team can build using Azure's application services, but have the flexibility to deploy it anywhere with Azure Arc. And so for this, we're going to take a simple website, but not just deploy it to the Azure cloud. We're going to deploy it to a different environment, in our case, on-premises. So to start, I'm going to start the same way I would build any web app. In fact, some of you watching here today at Ignite have probably done this before. I'm here in the Azure portal. I'm going to choose to create a web app. But I want to call out here is that you might be familiar with all of the different regions that Azure has around the globe. But now with this new capability, in addition to these regions, we allow you to deploy your web apps, your functions, your logic apps, all to custom locations. In my case, through Azure Arc, I have a custom location, which is actually on premises. So I'm going to select my on-premises Azure Arc environment as the destination that I want to run this web app. So let's go ahead now and fill out the resource group. We're going to give this a name. We'll call this our React app. And in my case, since it is React, let's go ahead and use Node. Now, once I have done this, the same tools that I'm used to using, in my case, the Azure portal, are going to spin up and create for me a web app. And while I'm able to manage it here within the Azure portal, the actual web app itself, all of the data, all of the code is going to be running in my Arc environment, in my case, on premises. So let's check out what that means with the Arc environment. And we'll walk through a few pieces here. So when I use Azure Arc, you can see I have a Kubernetes cluster on premises that while it is on premises, I have mapped to display here and be managed here through Azure Arc in the Azure portal. So it's projected here within Azure so that I can do things like set policy, maintain common logging and security. So like, for instance, here, I've gone ahead and created policies to make sure that things like every web application needs to make sure that it's only accessible over HTTPS. I want to enforce to make sure best practices around certificates are being created. This is the type of control I can now have in one spot, a single pane of glass, to control all of my applications. And what's nice too is I also get the productivity benefits of the application services when I use these combined. So we can see here is my app service, my React app, and we'll go ahead and browse to it now. I've configured my on-premises environment to be accessible through right here. So I'm able to call it. You'll see I have just a blank site. So now let's get some code running. And to make this complete too, as a developer, as I'm using these capabilities, I get the same productive experience that I've come to know and love with Azure with the flexibility now to run this on premises. So here's my React app. I want to get this deployed and running on premises. When I do this in Azure, it's a simple CLI command to deploy this to my web app. And with Azure Arc, it's the exact same. So I can go ahead and run this command to deploy my website to my React app. So let's go ahead here and put in the name of our web app that we just created. And so I'm just going to say, Azure deploy to this web app that we've created. I'm using Visual Studio Code. I could be using Azure DevOps or GitHub Actions. It's now taking this code that I'm showing here. It's sticking it in a zip file and deploying it to my web app. But this is all happening securely through Azure Arc. In this web application code is actually going to be running within my Kubernetes cluster on premises. So let's go ahead and check that out now. If we come back here to this web app, if I go ahead now and refresh it, here we go. Now my React app is up and running securely, in my case, on premises. So I've been able to use the same tools, the same set of best practices, but now with Azure Arc, I have the flexibility not just to run it within Azure, but in any cloud and any environment through Azure Arc. So now let's go ahead and shift gears and talk a little bit more about Kubernetes on Azure. Containers in Kubernetes increase application portability and promote a wide variety of application architectures to meet business needs. Kubernetes on Azure supports that flexibility, but also offers you an enterprise-grade tool set, all the way from development to platform. For developers, you can accelerate your containerized application using our suite of end-to-end tools, including GitHub and Visual Studio Code. From a platform perspective, we offer built-in best practices for our Azure Kubernetes service, which is using industry-leading security services to provide a multi-layered security experience, adding layers of isolation across your compute resources, data, and networking. We also work closely with open source communities such as the CNCF to develop key components for building and operating your clusters, bringing our knowledge of working with enterprises back to the community. With this set of tools, services, and projects available, Kubernetes on Azure gives you the flexibility of choice to support the application architecture that will meet your business needs. And no service is more central to cloud-native practices than AKS. Many of our customers rely on Azure Kubernetes Service because it is enterprise-grade by design. AKS has built-in best practices like Azure Advisor notifications to help optimize your Kubernetes deployments with real-time and personalized recommendations. AKS features multi-layer security with FIPS-compliant agent nodes, secrets integration with Azure Key Vault, and just-in-time cluster access with Azure Active Directory. AKS increases operational efficiency with support for automatic cluster upgrades. And you also have the ability to schedule service maintenance to occur only on off-peak hours. Every day, more customers are seeing success with AKS on Azure. And this is particularly true for customers who value the deep control and rich ecosystem provided by Kubernetes. For customers who want a managed Kubernetes control plane that can run anywhere, we recently announced the general availability of AKS on Azure Stack HCI. With AKS on Azure Stack HCI, customers can easily deploy a Kubernetes cluster that is consistent with Azure Kubernetes Service, fully supported by Microsoft, and 100% compliant on the open source ecosystem. Microservices architectures have become the de facto standard for cloud-native applications, and organizations continue to grow and adopt and harness the Kubernetes platform for their application and microservices needs. But along with the rapid volume of Kubernetes adoption comes the operational complexity to maintain and secure the vast amounts of application endpoints that exist in these environments. At Ignite, we're excited to announce the general availability of the Open Service Mesh Azure Kubernetes Service add-on. Azure customers will be able to experience first-class Azure support on a fully integrated cloud-native app stack. Customers can use the service mesh capabilities from OSM integrated natively with AKS. You can manage configurations such as traffic shifting, enabling certificates and MTLS, configuring access control policies, and getting rich monitoring and debugging insights for how your applications are communicating across the different microservices. So to show you this powerful new capability, let me hand it over to Philip for an amazing demo.
Okay, so in this quick demo, we'll be showing some of the most basic operations of a service mesh, which is to only allow authorized communications from services that you identify and allow to communicate to each other. And so in this demo, we already have our AKS cluster deployed along with the Open Service Mesh add-on. And we can verify that by querying the add-on profiles for Open Service Mesh, and you'll see that that comes back as true. Next, we'll deploy our test applications, our bookstore apps. We'll start off with the book buyer. Next, we'll deploy the bookstore. And finally, we'll deploy the book warehouse. Once all of those are deployed, we can go ahead and just take a look at our bookstore namespace to see everything that's deployed. And we see our bookstore is up and running. So next, let's go ahead and verify that we have communications prior to the Envoy sidecar proxy. So we'll query in on our book buyer. And then we'll go ahead and tail the logs of the book buyer. And you'll see that the book buyer can successfully contact the bookstore to purchase books. Next, let's go ahead and onboard our namespaces to OSM. So we'll add the bookstore, the book buyer, and the book warehouse. And now that we have our namespaces configured to be managed by OSM, we simply just need to do a restart on the deployments so that we can get our Envoy sidecar proxy. You'll notice here, if we look at the pods in the book buyer, you'll see one of one, so we only have our one application container. And so we'll go ahead and restart our deployments for the book buyer, the bookstore, and our book warehouse. Once those deployments have been restarted, we can take a look at the pods in the book buyer. And you'll notice that our pod now has a ready state of 2 of 2, one being the book buyer container itself, the application, and the second being the Envoy sidecar proxy. So now that we have our Envoy sidecar proxy, let's go ahead and ensure that our application can still communicate in the mesh. We'll also describe the book buyer here just real quick to show you the spec that we have our sidecar proxy Envoy container alongside our application container for the book buyer. We'll tail the logs off the book buyer. And you can see that it can still successfully speak to the bookstore going through the Envoy sidecar proxy. So next, let's go ahead and disable the permissive mode. And this is going to instruct the OSM controller to look for explicit traffic access policies to allow communication. And so you'll see that permissive mode is true. We'll go ahead and change that over to false. And then let's go ahead and see if our book buyer can still contact the bookstore. Okay, so we are getting an error message here. OSM does not have a explicit rule to allow the book buyer to talk to the bookstore. And so we are getting errors. So now let's go ahead and deploy a SMI traffic access policy, which is going to allow the book buyer to speak to the bookstore. And we'll now go ahead and tail the logs again. And you can see that the communication has been resumed.
That was awesome. Thank you so much, Philip. Now at KubeCon, we recently announced support for HTTPS proxies in AKS. This allows users to control the egress from their network for security while also successfully deploying to AKS clusters. You can learn more about our recent announcements and the roadmap for Kubernetes on Azure from our public roadmap. And you can learn more about the latest innovation across Kubernetes on Azure at azure.com. And finally, let's finish by discussing new updates to help you scale innovation across your teams. We want to bring the benefits of cloud native to every team and developer. With Azure, it's more than just having the tech. We're providing enterprise-grade experiences at every layer of your architecture with best practices baked into our support and product experiences. With Azure, customers receive proactive and actionable recommendations for securing resources, maintaining cluster hygiene, and increasing operational efficiency. These best practices are pulled from the thousands of customer engagements we have. We have 3,500 plus security experts who are focused on data security and offer 24/7 on-call support from Kubernetes certified experts. And we also want to partner together with the community in building great experiences. We continue to innovate with this community and have open source some of our core runtime, such as the Azure Functions runtime and cloud native innovations like Open Service Mesh. But today, when a developer wants the benefits of containers and microservices, they may hit a steep learning curve of complexity and concepts. Teams might feel that in order to get the benefits of cloud native, their only choice is Kubernetes directly. But Kubernetes is a layer on top of infrastructure with its own set of APIs and concepts that a developer will need to understand to get their code running. This can all add complexity, cost, and impact the speed in which a team can get their services running reliably and securely in the cloud. So at Ignite, we are thrilled to announce our newest cloud-native offering, Azure Container Apps. Container Apps provides the same microservices benefits as Kubernetes, but in a fully managed and serverless platform. This provides a path for teams to build microservices without having to overcome the concept and operational overhead of targeting Kubernetes directly. Build containers based on microservices, all with just your app and your code. Container Apps is the only serverless container solution offering a combination of both built-in HTTP-based autoscaling, including scale to zero, and event-driven based autoscaling to run containers that may be processing messages from queues, streams, or databases. Container App supports microservices architectures built with containers using any language, framework, or runtime. Container Apps provides native access to powerful open source projects and frameworks. Teams can write code in your favorite language and even accelerate development through the built-in integration with Dapper to simplify common tasks like service discovery, publish and subscribe, managing state, and more. Container Apps provides a streamlined code-to-cloud pipeline with integration with GitHub Actions. And finally, Container Apps is built on the foundation of powerful open source technology. Behind the scenes, every container app runs securely on Azure Kubernetes Service with open source technology like Kata, Dapper, and Envoy baked in. This lets you perform modern application lifecycle tasks such as application upgrades, traffic shifting, versioning, all ready to run for your teams from the get-go. I'm thrilled to show you how this works in action, so let's go ahead now and do a quick demo.
All right, so let's go ahead and take a look at Container Apps in action and see how it can help teams in building microservices faster than ever before. And what we want to build today is what I'm showing on my screen. This is a microservices solution. It's going to have a store API, which can call and get status around orders from a different microservices in that solution, and also call and get the inventory status. So let's start simple here and start with the store. So here inside of Visual Studio Code, I have a Node Express app. This is very basic. I just have a few endpoints. One, which I'm going to call to get the status order, which will eventually route to that order microservice, and also another one to be able to talk to the inventory service. Now, my project is working. I've already gone ahead and created a Docker container, and I've pushed that to my registry. So now let's see how quickly I can deploy this app to run on a serverless platform. So here I'm going to open up the Azure CLI and run a CLI command for AZ container app create. Now, while I go ahead and start running this command, let's go ahead now and step through and walk through some of the options that I pushed in here. So when I create a container, I'm going to go ahead and give it a name. I've gone ahead and named this our Node app. I'm going to associate with an environment. An environment can be within or outside my VNet, and it can define the service boundaries of which services can talk to other services. I also have here my container image. This can be any public or private container registry. I'm using GitHub packages. I'm also going to tell it which port my application is listening to traffic on. So here, my Express app is ready for traffic on port 3000. And I can define if this is externally available to someone in the outside, or if this service should only be internal, only discoverable by other services in the environment. And to make this demo a bit easier, we'll go ahead and set this as external. So now, after I've gone ahead and created this container app, you'll see here that it's going to spit out for me a URL that I can use to call in and trigger this container. So let's go ahead and copy this and move back over to our browser, and we'll go ahead and paste this in. And here we go. There's our Express app now running for us. And it's not just the container which is running in the cloud. You can see it's gone ahead. It's given me a certificate. I have a domain name that I can now use as I'm testing and debugging the service. What's great is if I went ahead now and hit this container with 1,000 requests, this container would automatically scale to handle the load. And at the same time, if I didn't hit this container with any traffic for a while, it can scale all the way to 0, saving me money on my next bill. Now, I don't yet have the other microservices deployed yet. So if I ask for something like orders or inventory data, that's not yet there to be returned. So let's go back to Visual Studio Code. I have here in the same project this Python service, which is going to return information on orders. And I have this Go service, which will return information on inventory. Now, what's nice is that not only can my container apps run these API microservices, I have this Java app, which is actually going to be listening to messages on a Kafka topic. In this case, I'm using the Kafka API on Azure Event Hubs. This container will process messages from Kafka, and just like my other containers, this will automatically scale on container apps. So if there are thousands of messages on that topic, it will scale to handle the load. And if that topic is empty, it will scale all the way to 0. So I can have different types of microservices as well. Now, I want to go ahead and show you how I'm actually securely calling things like that order microservice. So let's come here to the code in my store API of how I'm calling the service to actually give me best practices built in. And I'm going to do that by integrating with Dapper, which is built into any container app where I enable the Dapper feature. So here, instead of just calling the order service directly, I've actually written my code that's going to send this traffic to the Dapper sidecar. And the Dapper sidecar will then pass it on to the order service that I've defined here. Now, the reason that I'm using Dapper here is because just by routing my traffic through to Dapper, Dapper's going to give me a bunch of stuff. It's going to securely call this other microservice by managing MTLS for me. It will also make my process more resilient because if there are transient failures, Dapper can automatically retry. And Dapper's also going to add a bunch of rich telemetry, so I'll get a better view of how my microservices are talking and communicating with each other. So I have this built-in open source library support that I can turn on for any app that I want to securely call this other service. Now, I could go through the Azure CLI to deploy the rest of my services as I've shown here, but I likely want to go use something like CI/CD and best practices. Now, normally I would want a different release pipeline for all my microservices, but for the sake of the demo, I've added them all here. So I've configured GitHub Actions so that whenever I make a change to a microservice, it can automatically kick off the build step, publish that to my private container registry, and then deploy it securely to this serverless container apps environment. So now that I have all of the microservices available, I can go ahead here and call that order endpoint. And you see now I'm getting back that data securely routed from that Python service. And I can do a similar thing with the inventory endpoint. And it's now returning that back and telling me the inventory is in stock. We also get best practices here around visibility and observability. So because I've developed my solution in container apps and paired it with that Dapper feature, I can also see how my microservices are talking to each other. So you'll see here in Application Insights, I can use the app map. I can see that my Node app is calling the Python app and the Go app. I can understand the latencies of each of the steps here. So I understand how data is flowing and where my dependencies are across my entire microservices solution. We are absolutely thrilled to have container apps as a path for every team to build these microservice solutions on a fully managed and secure microservices environment.
You can learn more about Azure Container Apps or try it for yourself at azure.com. The future will be defined by accelerating innovation. Today, we talked about our latest innovation on cloud native and open source by sharing exciting news about the next generation of containers and serverless apps that will empower every developer to take advantage of these flexible choices in creating microservice applications on Azure. We cannot wait to see what you build. Thank you so much.